Swift-based language, you'll find this more natural. I'm going to cover the basics of the syntax and also the dangers of making too many assumptions from other languages. Imagine I gather a group of software developers around a table and I open up a simple program written in Swift. But without telling them what language it was, I asked them to tell me about it, what they could say about this mystery code. Now, first, they're likely to say, this looks like a C-based language. There's curly braces, there's keywords in lowercase, pretty classic structures like if statements. Next, someone might point out this code includes the word class, and the comments mention properties and methods, so it's probably an object-oriented language. And both of these things are true. Swift is a C-based language and Swift is object-oriented. And that's because although Swift is a new language, new in 2014, it was designed to feel familiar, so you could bring habits and skills from other languages. But familiar does not mean identical. There are a couple of obvious differences and some subtle, deeper ones. An example, if this is a C-based language, where are the semicolons at the end of each statement? And if this is a C-based language, where's the main method or the main function to identify the entry point of this program? So even in very simple code like this, two visible differences. Swift does not need semicolons at the end of each statement. They were necessary for older compilers to understand where one instruction ended and another began. But in the same way that, as programmers, we can read this code and easily make a distinction between one line and the next, so can a modern compiler. We don't need semicolons anymore. If you unconsciously add one at the end of a Swift statement, it won't cause an error, but the official best practice is to not write them. If you wanted to squeeze two statements onto the same line, you could use one, but it's rarely necessary. Not needing a semicolon sounds like a tiny thing, but it's an indicator of what we see again and again in Swift, a focus on simplicity, clarity, and readability. In Swift, if we can remove a character, or remove a word, or remove a line and not lose any meaning, we will do that. Another example is Swift doesn't need a main method or a main function to say where a program begins. Sure, we can control the entry point of a larger program if we need to, but it's not required. If you wrote some simple Swift code and ran it, by default it just begins at the top and works its way down. So even this would be considered an entire valid Swift program. Print is a built-in function in Swift, a simple way to output some text. Now I get it, it's easy to zone out with this kind of hello world example. You know you're never going to really write a one-line program, but this line is not what's important here. What's important is what you don't need. We don't begin this program with a line to import or include or link to some other library because the core Swift functionality already works without that. We don't need to wrap this in a main function or a main method. We don't need to return a result to the operating system. So a lot of the skeleton code that's just part of the landscape of other languages is not needed here because, again, if we can remove code and not lose any meaning, we will. So when starting to read Swift code, there are things you should bring from whatever background you have with C-style languages. Basic control flow, opening and closing curly braces, single line and multi-line comments. There are concepts you can bring from an object-oriented background, classes and objects, properties and methods, but recognize the syntax differences that add simplicity and clarity. We don't need semicolons. We don't need a main method. But beyond the obvious similarities and the obvious differences, there is a gray zone in the middle. First, there are places where a piece of Swift syntax might look new, but is easy to figure out. For example, this func keyword. This may not be familiar. It's a keyword you don't find in many languages, but if you guessed we use it to define functions, blocks of code that take parameters and return values, you would be absolutely correct, and we will dive into this syntax in just a few minutes. But there are also places where a piece of Swift syntax might look similar to something you already know, but is actually deceptively different. Here I've got some Swift code using the var keyword. Var, or some people say var, is not an unusual keyword. If you've programmed JavaScript or Go, you'll have used it. And if you make the reasonable assumption we use this to define variables, you would be correct. However, beyond that, assumptions are dangerous. Notice I'm not explicitly providing a data type for any of these. I seem to be creating a string, and then an integer, then a float, then a boolean, and it would be very easy for a developer to read this and assume that Swift is flexible with its data types, like JavaScript, where a variable could begin as a string and then change to an integer and then become a float or even an object. But that assumption would get you into a heap of trouble. Swift is most definitely a type-safe language, and there's more going on here than is immediately obvious. But the way to make this obvious is for us to start writing and running it. So let's talk about creating variables and running Swift. When you want to write and run a few lines of Swift, whether you're learning a new piece of syntax, you're experimenting, you want to test an idea, the easiest way to do that without all the extra weight that comes with a full project is to create a playground in Xcode. And that's the first option on the welcome screen. If you've dismissed this, you can just use File, New, Playground. This is a special file type, a single standalone file for us to write Swift in, but not just to write it. Playgrounds let us test, interact, and view the results of Swift code as we're writing it line by line. So I'll give this a name, and then I have to choose if I'm using this for iOS or OS X. We have to pick one. It doesn't really matter here. I'll pick iOS. Click Next, and I'll go ahead and create this single file on my desktop. You can put playgrounds anywhere you like. There's no special place for them. Now, choosing that iOS option a moment ago added this import statement to the playground. But wait, Simon, you say. In the previous video, you said we didn't need an import statement. And that's true. We don't need this line. It's here in case we want to test an idea for an iOS app and we want to use iOS objects in our playground code. For now, we don't need this line or the other one. So I'm just going to select them all, delete, and we'll start from a blank slate. So we used the keyword var to declare a variable in Swift, followed by the name we want to call that variable. In Swift, as in many languages, the naming convention for variables is camel case. Start with a lowercase first letter and capitalize any subsequent word. This code by itself is not valid. It's not complete yet. Xcode automatically attempts to parse our code as we're writing it, and I'll see this error symbol in the gutter on the left. I can click that symbol to get a bit more information. I can click the symbol again to toggle that information off. Now, to finish this line, I'm going to provide an initial value for this variable. Just set it equal to a string of Alice. This error goes away. There's no symbol in the gutter. It's now a valid line of Swift. Now I'll create a few more variables using the same format, but setting these variables to different kinds of initial values, different types of data. If we think back to our imaginary group of developers, if I'd asked them to describe these values, they'd say, well, the first one looks like a string, the second one's an integer, the third is a floating point value of some kind, and the final one is a Boolean. And you know, right now, the Swift compiler is doing exactly the same thing, because when we declare variables and provide initial values for them, Swift looks at those values and infers the data type, what's called type inference. So the value Alice inside double quotes is inferred as a string type. So this is strongly typed as a string. Likewise, age is typed as an int, temperature is typed as a double, which is the default floating point data type in Swift, and active membership is a bool. Again, Swift is a type-safe language, and Swift will check that your types are correct and consistent at every possible opportunity throughout your code. So once Swift has inferred a type as a string, if I try and go ahead and treat this like it's an integer, I'm going to get an immediate error. You might be able to get away with this kind of vague and ambiguous code in JavaScript, but you can't do this in Swift because it will enforce your data types. And for those of you who are coming from any JavaScript background, you're probably very familiar with the keyword var, but you might think of this as a word that's useful but optional. It might be a best practice, but it's not technically required. You don't have to use it. And you could be wondering, is that the same in Swift? So let me be clear. No, absolutely not. Here in Swift, var is not some voluntary keyword to use at our discretion or only in certain places. It is required. And in case you're wondering, var is also not one of several alternatives we might choose from when creating a variable. It's all we have. There is one, just one, and only one keyword to declare a variable in Swift, and that's var. Back to the playground. You've probably noticed this gray section on the right-hand side. This is the results sidebar, and it's what makes the difference between having a Swift playground and just editing code in a text file. This continually shows the results of our Swift as we're writing it, and without us needing to explicitly compile or execute this code. By default, it just keeps continually updating. But it's not just final results, final output. We'll see the effects of each line in turn. Now here, it's just the values of these variables as they're created. But if I had a simple line to perform a basic operation, say changing the value of the age variable, we will see the results of this. Age, which starts at 21, plus 5 is 26. But we will see the earlier value as well up here at the top, and any changes to that value later in the code. Notice that I don't have to write an explicit statement to print out a value. It's automatically showing me the results of the operations on each line. Now these results here are shown in black, but as I make changes to the code, you'll see those results dim to gray for a moment and then back to black. And it's while the playground is re-evaluating the code, because any change earlier in the code, say changing age to 99 on the second line here, is also going to change what happens later in the code, so the entire playground is re-evaluated after any change. Now, if the results stay gray or are staying gray, something is wrong somewhere. If I have an error in my code, all the results will dim to gray in the sidebar. I can look for the error symbol in the gutter, and it's here, because until I've fixed whatever errors exist in the playground, it won't re-execute any of the code. Now, there are a few more interesting features of playgrounds, but we need more interesting code first. We've created some simple variables with explicit values. It's time to see what happens when we can't provide this initial data. So we have this straightforward format to declare variables. We use var and we'll get automatic type inference if we provide an initial value. But what if we don't have that? What if we need a variable, but we can't provide a value for it? Maybe we expect to read it in from a database or get it from the user. Well, we still use var, but if we don't provide a value for Swift to infer, we must explicitly provide a type for this variable. That's why this code is not valid. Swift cannot tell what this variable is, and that's unacceptable. So to provide a data type for this, after var and the variable name, we put a colon, a space, and then the type. So an example, colon, space, string. String is a built-in type in Swift, and in Swift, types begin with an uppercase letter. That's it. The error goes away. Swift is now happy. It knows what this is. You can think of this colon as meaning of type. So this means make a new variable called user nickname of type string, or make a new variable called population of type int. You can put a space between the variable name and the colon, and I'll admit I find this format quite readable, but the convention in Swift is that we don't. It's usually no space before the colon and one space after the colon. And these two pieces, the colon and the type name together, is called the type annotation. And if I don't have one, that's the error we've been getting in the playground. Type annotation is missing. So what are the choices? Well, there are several basic types already built into the standard Swift programming language. We have what you might call the usual suspects. Int for integer values, a very powerful Unicode-aware string type. Double and float for 64 and 32-bit floating point values. Bool for true or false. There's also uint for an unsigned integer, a character type for a single character. But you know, I'm not going to try and be exhaustive here. This is not the time or the place. Of course, there are other options. If you're declaring, say, an integer variable, you will see Xcode's autocomplete pop up different options, not just the standard int, but you get things like the specific 16-bit integer or even an 8-bit integer. Now, if you want to dive deeper into the details of any particular data type, I will leave that to you in the documentation. There are also built-in collection types in Swift. There are arrays, dictionaries, and sets. These are all part of the standard Swift language, but we will explore collections a little later on. Now, more complex types, things like date objects or time zones or threads in an application or a button in an iOS app, those are not part of the standard Swift language itself, but we can get access to those by importing frameworks that Apple provide for iOS or Mac development, and we'll be doing that very soon. Now, you could write both a type annotation and provide an initial value, but there's usually no point. If you have the initial value, you shouldn't need the type annotation. Now, there's one last thing I want to cover before we move on. I've talked about using the keyword var for all variables in Swift, but I'm going to suggest that wherever you use var, you look closely at that piece of data and see if you can replace the word var with another keyword, the word let. Notice I can just swap one word for the other. Using var creates a variable, and using let creates a constant. So once you provide a value, you can't then change it. Other than that, the syntax for let is identical to var. If you provide an initial value for your constant, like I'm doing with player name and age, then Swift will use type inference. If you don't, then you must provide a type annotation, and you can later set the value of it, but either way, it can only be initialized once. Any attempt to change it after that would cause an error. Okay, it's true many programming languages support the idea of constants, but you'll find Swift places a strong emphasis on these, with a recommendation to use let wherever possible. Part of that recommendation is for code safety. You're imposing restrictions on what pieces of data can and can't do, and that makes things more predictable and more controlled. But another reason is the Swift compiler can perform optimizations on data if it knows it isn't going to change. Now sure, if you need a piece of data to represent the volatile changing score in a game, or the value of a selected cell in a spreadsheet, or the current amount of seconds into a playing audio track, then sure, use var. But you might be surprised by how often you can use let, when pieces of data just don't need to change within the lifetime of a program, and you will see a lot of constants used in Swift. If Swift was exactly the same as other C-based languages with its control flow statements like conditions and loops, I would skip some of this. But once again, while Swift is familiar, it's not identical, and it's worth taking a moment to cover a few differences so we can write Swift that looks like Swift rather than writing Swift that looks like Java or C#. So we begin with the most basic fundamental condition, the good old if statement, or optionally if else, with a format that's recognizable and readable across dozens of programming languages. But here's our two important differences. Number one, in Swift, no parentheses are needed around a condition. They don't add anything here. By removing these, we don't lose any meaning, and we make it simpler and more readable. So away they go. Now, if you have a complex condition with multiple pieces to it, you might add parentheses to make things clearer and more logical, but they're not required. Difference number two, in Swift, curly braces are required around each branch, even for single-line situations. In many C-based languages, this kind of thing would be acceptable, with no braces where we just execute a single statement if this condition is true. This isn't allowed in Swift because it's a common cause of bugs. Even a single line must be wrapped in curly braces. I'm using the Swift print function here. In Swift version 1, we tended to use the print line or print ln function, but in Swift 2, print automatically adds a line break at the end. All right, moving on. We have the classic while loop. As long as the condition is true, we will continue to execute whatever's in the body of the loop. Well, in Swift, as with the if statement, no parentheses are needed around the condition, and curly braces are always required. But if you know the while loop, you probably also know its lesser used cousin, the do while loop, with the condition placed at the end and where the body of the loop is always executed at least once. Well, you used to be able to write a do while like this in Swift, but not in Swift version 2. It's been renamed. If you need this behavior, Swift calls it the repeat while statement, and it looks like this. Again, we don't have to enclose the condition in parentheses, but we do have to include the body of the loop in curly braces. Okay, Swift also has the classic C-style for loop with three elements. We have the initializer, we have the condition, and we have the increment. A simple example here. Here's a classic for loop to go from 0 to 9. We write the three pieces of code to initialize a variable, to create a condition to check its value less than or equal to 9, and then to increment it at the end of each loop. Once again, in Swift, we don't need parentheses around these three elements, as you would in many other languages, and of course, curly braces are required for the body of the loop. However, you won't see as many of these classic for loops because we have an alternative, the for in loop, and that allows us to easily iterate over every item in a sequence. A sequence could be a simple sequence of numbers, could be a sequence of characters, it could be a sequence of objects, like all items in an array or all images in a folder. So I could write the for in version of this here. Now this simpler format is using these three dots between 0 and 9. This is known as the range operator, and this generates a sequence in Swift. The sequence will begin with whatever number is on the left-hand side of the three dots and end with whatever's on the right-hand side of the three dots. So here, 0 through 9, including both 0 and 9. So both of these loops are doing exactly the same thing. I get a bit of a message over here that they're going around 10 times. I can see that in my playground. Now, if I wanted to generate a sequence in this original for loop that's like a less than situation instead of less than or equal to, So go around as long as I is less than 9. Well, this is very common when working with collections like an array, where you need to be able to start at 0, but your condition you're going to check is to go to 1 less than the number of items in an array. Well, I can easily also do that with the for in version 2. I use a slightly different range operator. Instead of the 3 dots, it's 2 dots and a less than sign. This syntax also generates a sequence, but now it will go from 0 on the left to 8 on the right, 1 less than the number on the right. And I see this feedback in the results pane here that they're both going around 9 times. I'm using I here to represent the index, but this is just whatever we want to call it. I, index, foo, whatever I call it in the for in statement is what I need to use within the body of the loop itself. Now, it's not just numeric values, though. This for in statement can iterate over sequences of characters. It can iterate through collections. So we'll see this a bit more useful later. There's a feature of Swift, a feature you won't find in many other languages that will prove essential for us to work with iOS, and that feature is optionals. And we can use optionals without iOS. These are a fundamental part of the Swift language, but we'll need them again and again and again when we get into iOS development, so now's the time to cover the basics. Here's the deal. As we've seen, Swift is picky. It enforces type safety. If you say a variable or a constant is a string, then it always has to be a string. And Swift will do type checking when you change your variables, and it will also make sure that those variables and your constants have a value at all before you try to use them. Here's what I mean. We've seen we can declare a variable without any initial value by using a type annotation. This line is fine by itself, but Swift won't let us actually use it if we haven't provided a value. If I attempt to use this variable within a print statement to print it out, I'm going to get this error here. And that's because variables in Swift are not automatically initialized to default values like an empty string or 0 or false, the way they might be in some other languages. Now, the simplest way to fix this right now is I just provide a simple value for this variable before I try to use it, and then the error goes away. The contents of this variable now become part of this message that I'm spitting out here in my print statement. And as a side note, the syntax I'm using here is called string interpolation. The way it works is that inside a string literal, I can put a backslash and pair of parentheses as a placeholder. And then whatever I put inside these parentheses, like a variable name, well, that variable name will be treated as an expression when this string is created. So the value of the variable will be used to create the string. And you can even use it multiple times, having multiple variables or expressions within those placeholders. It's a very readable, very compact syntax to create custom strings without concatenation or format specifiers. Back in our code, so this variable is just normal. That means it's required to have a value in Swift. That's not optional. But sometimes there is a completely legitimate reason for a variable or a constant to not have a value. Not be an empty string, not be 0, not false, but have no value at all. And that's what optionals in Swift allow us to do. So an example, let's say I want to make a program to store employee information, and I need some data to represent first name and last name and things like employee number. I'll create these as variables using var, but assume everything I'm saying here applies to constants too. But I also have pieces of information like this. We've got middle name, we've got passport number, we've got things like phone extension. And these are different, and not technically, they're just different within the real world ideas of my program, because sometimes a person has a middle name and sometimes they don't. There's a place for a passport number, but this person might not have a passport at all. There's a place for a phone extension, but likewise they may not have one. And we don't want to have to do some kludgy workaround and set these all to some generic dummy default value and then check the logic of that later. We'd just like to be able to say that these three are allowed to not have a value. So we can define these three variables as optional, and to do that, we add a question mark right after the type. That's it. These are now optional types. Middle name is not a string, it's an optional string. Passport number and phone extension are optional ints. Now, optional does not mean a flexible or ambiguous value. These are still strongly typed. Adding this question mark after the string type and middle name doesn't mean it's possibly a string, possibly a Boolean, possibly an integer. No, it's either a string or it's nothing. Passport number is either an integer or it's nothing at all. Now in Swift, we use the keyword nil for the idea of no value. In fact, you see it over here in the playground results for these three optional variables because it is an allowed value. These are allowed to be nil. Now you might think of this as equivalent to null in some languages, but there is a difference. Null is usually a word that only applies to objects, but in Swift, any type can be defined as optional and have a nil value. Objects, integers, booleans, whatever type you have can be defined as an optional type. But there's two parts to optionals in Swift, because if we say that these variables are allowed to be nil to not have a value, then later in our code when we use them, we can't just assume that they have one. They may not. So we need both this change in syntax when declaring optionals, and we need a change in syntax when using those optionals. And if you hear that and think, oh, well, this sounds like a pain, I just won't use these very often. Well, you'll have no choice. I mentioned optionals are so important in iOS development, and that's because iOS was around for years before Swift came along. So most of the iOS frameworks, this massive amounts of useful pre-written code that Apple have provided for iOS development, well, they weren't written in Swift. They were written in Objective-C, a very different language, and one that's, well, it allows nil values everywhere. So, optionals are one of the features of Swift that will allow us to use all this existing functionality without having to be an expert in Objective-C. So let's cover how we use optionals, whether they're ones we've declared or ones that somebody else wrote. If we're dealing with optional values, there are extra steps we have to take. We can't treat an optional value exactly the same as a regular non-optional one. Well, sometimes we can. There are times we can treat them the same way. So I've got two variables here. One is of type int and one is of type optional int here using the question mark. Now notice in the playground that the optional int immediately shows up as nil, which for this is an allowed value. I can directly set either of these to an integer value. This code works for regular int, it works for optional int, because for this line, it doesn't matter what the value was previously or even if there was a value. I can also explicitly set an optional variable to nil if I wanted to remove the value. I couldn't do this for the regular int, that would cause an error. However, the real difference is when later in my program, if I want to perform some operation on these, like adding 5 to the current value of these integer variables, well, I can do that fine with the regular int, but I'll get an error with the optional int, because adding 5 to a value assumes there is an existing value for us to add to. But this is an optional. We might have a value, but we might not. To deal with this, we have to understand that when a type is defined as optional, it's as if we take the underlying data type and wrap it up. We take that integer, or that string, or that object, and we put it inside this optional container, and this is our optional. Now we can ask this container, this wrapper, are you nil or are you not nil? And if that optional is not nil, then we'll know it contains a value, and we need to pull that value out, and that is called unwrapping. We can unwrap an optional to get to the actual value inside, but we only unwrap if we know there is a value. So I'll comment out this line where I'm trying to change the optional integer. There are a couple of ways to unwrap. First, we can explicitly ask the optional, are you nil, or what we're more interested in, are you not nil? So if optional int not equal to nil, then we know this now contains an integer value. Now, what I'm going to do is create a new variable from optional int and follow it with the exclamation mark. This is what unwraps the optional, and it will pull out the integer that we know is inside this optional. We used a question mark to declare it as an optional. We're using an exclamation mark to unwrap the optional and get to the value. Now, using the exclamation mark is known as forced unwrapping. It assumes we have taken care of checking for a non-nil value, because if I use the exclamation mark to forcibly unwrap an optional, but the optional actually is nil, it will crash the program. Let me say that again. If you force unwrap an optional that's actually nil, you will get a runtime error. Now this new variable I've created, this will be strongly typed as a regular int, not an optional int, because Swift is doing type inference. We provided its initial value here by unwrapping our optional, which means we unwrapped and pulled out a regular integer value. So it's a regular int now, and I can add code to manipulate and use the value in unwrapped int, and there'll be no problems. So this is one way to do it. But there's another, an alternative format for unwrapping optionals that's more of a shorthand. It doesn't require an explicit not nil check, and it doesn't require the exclamation mark, and that is this way, using the if-let structure, the if-let syntax. Now, this might look a little strange the first time you see it, but you'll actually see it a lot. The way you should read it is really this part first. Let unwrapped int equals optional int. Now, even though we're not using the exclamation mark, when it's written here in an if statement, this will attempt to unwrap the optional int and create a new constant, because I'm using let here, from the inner value. Now, if it works, then there was actually a value in that optional. We'll have this constant created. It will exist within the body of this if statement. We'll drop into this block because it'll consider itself as true. But if the optional was nil, we can have an else block and we would drop into that. We wouldn't get a new constant created. We wouldn't have this thing called unwrapped int to deal with. But notice we're not using the exclamation mark anywhere here. So it's a more straightforward syntax, and you will see this a lot. Now, this method is known as optional binding. It's one of several ways that we can actually deal with optionals when we're working with Swift. But for the time being, those are the two common ways to deal with them: forced unwrapping and optional binding. There are other ways we can deal with optionals, and we'll see some of that when we get into iOS. We're not going to just write line after line of continuous code all in one file. We will, of course, build our programs in reusable, modular, manageable pieces, both by defining and using classes, which we'll see in a moment, and by creating reusable chunks of behavior, functions, where we'll take some code, make it self-contained, give it a name so it can be repeatedly called. Now, if you're an object-oriented developer and you're slightly zoning out, thinking, I'll wait till he starts talking about methods, this is that moment. In Swift, a method is simply a function that you've written inside a class. It's the same syntax. And here is that syntax. It's the keyword func, F-U-N-C, and whatever you want to call your function. Now, as with other languages, our functions can have parameters or they can return values, but we'll begin without either of those things. So after this function name, create message, I'll add opening and closing parentheses. In Swift, we've seen that parentheses can be optional around things like simple conditions in if statements, but in a Swift function, the parentheses are required because they have meaning. This explicitly says this function takes no parameters. So I'll open the curly braces and I'll add some basic code. Our function will be defined. I'll create a message here and then I'll spit that message out. But of course, there's no point in defining a function unless you're going to actually go ahead and call this. So to call a simple function like this one, I just use the name of the function. We're getting this autocomplete here, create message, and again, empty parentheses. I'm passing in no arguments here. All right, this is pretty simple stuff so far and shouldn't really be surprising anyone. Now, function can also return a value. In many languages, you would put the return type before the function name, but not in Swift. In Swift, the return type comes after the name and after any input parameters are defined, and it looks like this. We have the arrow here that tells us that this function returns something, and then after the arrow, what type it returns. Now, I really like this format, this sequence of defining things, because it's the way most programmers would naturally talk about a function if asked to just describe one. I'd say it's a function called create message, it takes no parameters, and it returns a string. But if we say we're going to return a string out of this, well, we better actually return a string. So I'll just add a return statement to return that message constant that I'm making. Now, right now, our call at the bottom still works. It's just ignoring any returned value. But I could also use the value being set back from this, just say let result equals whatever comes back from create message. Now, result will be strongly typed as a string. It'll be type inferred as a string because the return type of my create message function is a string. So moving on, let's add a parameter. Inside the parentheses here, I'm going to add a parameter name, then a colon, then the type. Very similar to how we're defining either our constants or our variables. So this function, create message, now takes one parameter called some number of type int. And inside the body of our function, we can now decide to use that parameter. However, there is a problem. I can see all my playground results over here are grayed out, and down here I have the error symbol in the gutter. That's because our call is no longer correct. There is no function called createMessage that takes no parameters. So we do need to change this to pass in an integer. So I'll just pass in the number 99. That should fix it, and the playground gets re-evaluated. So far, so good. Many of you may be thinking, everything's pretty much behaving the way I thought it would. And that's great, but the next two pieces of information I'm going to say may change that. One, it is important to understand that when we define parameters on functions, by default, a parameter passed into a Swift function is treated as a constant, not a variable. This is an immutable value. I can't actually change this. If I try and say some number plus plus, expecting to be able to change the integer passed in, I'll get this message. You can't pass an immutable value to a mutating operator. It's a let constant. All right, true, it is possible to define this parameter as a variable by explicitly adding var within the parentheses here before the parameter name. But once again, it is the default behavior of Swift to lock things down unless told otherwise. Many languages would default their parameters to being variables, but Swift defaults them to a constant. Okay, moving on. Let's say multiple parameters. I've decided that I want to be able to pass two numbers into this function. That's easy enough to define. Within the parentheses, within the parameter definition, after the first one, I'll have a comma, and then I'll follow that with the second name colon type. So we've got a parameter called second number of type int. Once again, that's going to now mean that our createMessage call doesn't work anymore. We're seeing all the results grayed out over here. Now, here's the thing. A lot of people would expect to write something like this. We'll just write 99, 100, passing in two integers, but this will not compile because Swift syntax is different. Now, thankfully, in Xcode, if you click the error symbol in the gutter, you'll get a little prompt. It's missing the argument label, and there's a fix-it suggestion. What it's doing is recognizing that you've tried to do simple C-style syntax for calling this function, and that's not going to work. It will help you correct it to Swift syntax, so I'll do that. Here's the deal. In Swift, if your function is defined with more than one parameter, whether that's 2 or 3 or 4 or 20, then when you call that function, inside the parentheses, every argument from the second one onwards must be prefixed with its corresponding parameter name and a colon. So we're saying we are passing in 100 to the second number parameter here. It's a style of syntax that is taken from Objective-C, which also used named parameters when calling. And again, Xcode will help you if you forget to do this. But this is the format to expect when you start creating and using all the built-in classes in the iOS frameworks. And speaking of classes, that's up next. Swift is an object-oriented language. iOS is an object-oriented framework, so we'll be defining our own classes and we'll be instantiating objects from those classes and from classes that other people, particularly those at Apple, have written. As with functions, there are, of course, two pieces to the syntax here, a syntax to define classes and a syntax to instantiate objects from them. Well, first, let's go ahead and define one. It is simply the keyword class. We get a couple of options popping up here in the code sense in Xcode. I'm going to use the normal Swift class, hit tab. We have to provide a name. I'm going to call this one appliance. Now, because we are defining a new type, the convention is we use an uppercase first letter. So the class itself is contained inside curly braces. I see a code completion hint here to add properties and methods to our class, defining state and behavior. And the wonderful thing is we already know how to do this. So just tab, and I'm just going to start adding properties to our class. And to do that, I just start adding variables and constants, and that's it. There are no special keywords needed. A variable or constant defined inside a class becomes an instance level property of that class. So you can use var, you can use let. If you use let to create a constant, it follows the same rules. It can only be given a value once. And we have the same rules with our types. If you provide an initial value, Swift will infer the type. And if you don't, you need the type annotation as I'm doing here. You can also choose whether or not you want to define anything as optional. Now, Swift right now is complaining that nowhere are we providing any way to initialize objects of this class in some kind of valid state. And that's just as we can't use a variable without giving it a value. Swift won't let us instantiate an object without explicitly saying where this object's going to get their first values from. It always has to exist in a valid state. So I can either provide an explicit initializer method in this class to make sure my values are set, and we'll do that in a moment, or I can provide explicit initial data for each of these variables that aren't optional. And for a quick and dirty solution, I'll do that. I'll just select the Fix It option here for manufacturer. There's another one for model. And there's another one for voltage. Now here it's just really setting them to an empty string for the strings and a 0 for the integers. But at least we now have a few properties and the error goes away. Next, to add a method to a class, just add a function. Again, that's it. No special keywords needed. A function defined inside a class becomes an instance level method of that class. So I'm going to construct a message, do a little bit of an if statement, change that message if the if statement is true, and then finally output the end result of that. And we have one method. Now, Swift uses the keyword self to refer to the current instance. You might be used to the keyword me or the keyword this instead. Now, technically, I don't actually need to write self here. Swift would assume that I was referring to the model property of the current object or the manufacturer property of the current object, but I wanted to be able to point out the keyword. So we now have a class defined with defined data and behavior. In a typical project, we'd write each class in its own code file. I'm just putting them all in a playground to keep things simple. The second half of the syntax,
I realize there's a good chance
somewhere else in the app, somewhere later on,
we
want to be able to
in iOS, we
use
objects
delegation
in places
in
where
Swift,
a Java
we don't need the
developer would
keyword
assume we
new
use
or
enhancements.
alloc or init
So if you don't
or any special keyword to say we're making a new object,
different mode,
we just use the name of the class followed by empty parentheses means in this case create a new object of the appliance class. So this new variable that I'm creating, the var cattle, will be type preferred as an appliance object. So Xcode realizes that if I start using it and say cattle.m, I'll get the manufacturer property, I'll get the model property. I can use .syntax to access or change the properties of this object and call its methods. So a very simple, very straightforward way to create new objects and then just using .syntax to access properties and methods of those objects. Now there is an alternative way to make sure that this object, this class that I've defined, always creates objects in a valid state, is rather than provide these initial values, which you can't always do meaningfully, so I'll just go ahead and delete them. That will bring up an error, but we'll fix this in a second. We can create
there's a good
initializer method.
You've created some iOS data to show different information.
That just means adding a method called
multi-line labels.
We don't
by
need
default they
Func
are only
Keyword before an init.
line.
It is understood that this is a special initializer method, and if we write one, the init method will be automatically called when we create a new object. Similar idea to constructor methods in other languages. So this is the default initializer now, init, that takes no parameters, and it will set up these values as the default. You can create multiple initializer methods as long as they have different parameter signatures to tell them apart. All right, we have covered a lot over the last few minutes. Let's review. If you were new to Swift at the beginning of this module, you should now be feeling a little bit more comfortable. Now, you should still have questions. We weren't trying to explore everything. After covering the basics of the syntax, we used Xcode Playgrounds to start writing Swift, a great interactive environment for learning and experimenting with code. We talked about creating variables with var and the preference for constants with let, that Swift uses type inference to infer data types when it can, which leads to simpler, more readable code. But Swift is most definitely a type-safe language, and if you try and behave as if it isn't, Swift will rudely remind you of that fact again and again. After covering some differences in program flow, we then explored the idea that variables and constants can be defined as optionals, meaning that they either have a value of a specific type or they're nil, they have no value at all, but that if an optional has a value, we will unwrap the optional to get to it, a very important part of Swift and particularly with iOS development.
We then explored creating functions, defining parameters and return types, and moved on to defining classes and instantiating objects. We will see more Swift as we go forward, but it's time to get back to iOS.